So in these two problems, we have a similar idea. We want to take out a GCF, but first I need to add cosine to the other side, so my equation is set equal to 0. And then I'll take out my GCF of cosine of theta. So I'm working with cosine theta, parentheses cotangent theta plus 1 equals 0. And I have two factors I'm going to set equal to 0. First one, cosine theta equals 0. And I know that cosine is 0 at two angles, 90 degrees, and at 270 degrees. So that's done for cosine, but we also need to set cotangent theta plus 1 equals 0. And when I solve for cotangent, cotangent equals -1. And I'm going to write that as a ratio of -1/1. And I know that cotangent is adjacent over opposite, so I'm going to create my triangle, which is a reference angle of 45 degrees. And I know that cotangent is negative in two quadrants, quadrants 2 and in quadrants 4. So I'm going to be plotting my 45-degree reference angle in those two quadrants. Quadrant 2 will be 180 minus 45, which is 135 degrees. And quadrant 4 is 360 minus 45, which is 315 degrees. In this last example, this is a factoring problem. So with the signs, I can change out sine theta with just a variable if I want to make it something that's a little easier to understand. So 3x squared minus x minus 2 equals 0 would be something that would be more familiar with factoring. So when I factor that and I find the correct combination of factors, I get 3x plus 2, x minus 1 equals 0. And if I were to solve that, you would get those two values as your x values. So we're going to do the same thing with sine. I'm going to factor that so that it becomes 3 sine theta plus 2 and sine theta minus 1. I'll first set 3 sine theta plus 2 equal to 0. And when I solve for it, I get sine theta equals -2/3. Now this isn't one of the special right triangles that we know. This is actually not any of a 30, 45, or 60. It's not any of the quadrantals either. So this problem will actually require a calculator in order to approximate a value. So since our problem is in degree, we want to make sure our calculator is in degree mode. And we are going to use inverse sine in order to find the correct value. So inverse sine of -2/3 is going to be approximately -41.81 degrees. So that is my reference angle. But for my reference angle, I'm going to make sure I use a positive value. And based on the fact that sine is negative, I'll determine where to place this 41.81 degrees for the quadrants. So sine is negative in quadrants 3 and in quadrants 4. So I'm going to go ahead and do 180 plus the reference angle and 360 minus the reference angle to find it in those two quadrants. So I'll have 221.81 degrees, as well as 318.19 degrees. When I set sine theta -1 or -1 equal to 0, that means that sine theta equals 1, and I know that sine is only 1 in one place. It is only a value of 1 at 90 degrees. Therefore, for my question here, I have three answers. I have theta equals 90 degrees, theta equals 221.81 degrees, and 318.19 degrees.